So this is a demonstration of our project titled Revolutionizing Agriculture Through Smart Farming by Employing Advanced Machine Learning Techniques for Optimal Crop Selection. Okay. So here I am going to demonstrate the hardware components we use for our project. Okay. See, this is the main thing, a box of soil, okay, which already having some moisture content. Then this is our 4-in-1 soil meter, which will test or give you the value of NPK, nitrogen, phosphorus and potassium. Okay, see, this is the one. You have to turn it on. Once you turn it on, this one, first one, nitrogen, okay, N31 mg per kilogram. Okay, then we have phosphorus 35 now, and this one is potassium 77. And what is Te? Te means along with this nitrogen, potassium and phosphorus, we have trace elements. That means some micronutrients like boron, zinc, iron, magnesium, copper. These are all are related to metabolism in plants. Okay, this is the NPK soil meter. Then we have groove soil moisture sensor. Okay, so this sensor will read how much moisture content available in the soil. That's why I'm dipping these two inside the soil. Then I have temperature humidity sensor, DHT11. Okay, temperature humidity sensor, which will actually measure the temperature and humidity of that particular location where you are testing this. Okay. Some people even to put this in the soil. Okay, here I'm just putting it outside, keeping it outside. Then I have the main component, my microcontroller, Raspberry Pi. This is a Raspberry Pi, this one. Okay, Raspberry Pi 4, and that device is the computer. This is the one which get the data from sensor and process the data. Then on top of this, I have Group Pi board. Okay, Group Pi. This is a board which is a plug and play device. This is connected to Raspberry Pi on top of Raspberry Pi. Okay, then the sensors and actuators are all connected to this Group Pi board. Instead of directly connecting the sensors to Raspberry Pi, I am connecting that sensors onto Group Pi board. So this is temperature humidity sensor. It is connected to digital port 7. Okay, and this my soil moisture sensor is connected to A1 analog port. Okay, and this soil meter, I just check the value and update in the program. Okay, just I'll turn it on. So here I am getting the value 60, 20. It's keep on. Okay, it's keep on changing based on the soil moisture content. Okay, this is my hardware setup, and this Raspberry Pi is connected to the USB port, okay, of your laptop to get the required power. Okay, and I have used Python programming. So this is my Python code. Okay, this is my Python code for this program that I will explain. So as I told you, this is our Raspberry Pi notebook window. So we are using Cisco PLApp tool. In this is a notebook where I can save my files. So my file, the Python program is here, soil project.py. So I'll open that program. This is the program. These are all header files, the header files, packages. Okay. So we have temperature sensor, which I am going to connect in digital pin 7, which I already shown the topology. Soil moisture sensor I connected in analog port 1, so A1. Then I make the soil moisture sensor as input device. Okay. That 5-volt voltage for running this device. Okay. Then I read the temperature and humidity. So I use the function groupi.dht. So dht11. So okay. So dht of sensor comma blue. So sensor is seventh pin blue. The temperature sensor will have two colors, blue and white. If you're using the blue sensor, make it blue here. Okay. Then this one function will read temperature and humidity, and I'm going to print that temperature humidity if it is not, it is having a number. Okay. So if math.isNan of temperature equal to false and if math.isNan of humidity equal to false, that means is not a number of temperature is false. That means temperature is a number. And is math.isNan of humidity equal to false, that means is not a number of humidity is false. So both are numbers. Then you should print the temperature. This one for displaying the value in decimal number, and after the point 2 digits, that's why. Okay. Then humidity also we are printing, temperature humidity both we are printing. Then I'm reading the value of which one, soil moisture sensor. For that I use groupi dot analog read. Why you are using analog read? Because I am using connecting the soil moisture sensor in analog port A1. So I'm reading that value of moisture, soil moisture using analog read, and I store into SM, just a variable. Okay. Then I print the value SM1, both are same. Okay. Then this NPK values, no, which I get from the 4-in-1 soil tester, that NPK sensor, no, NPK tester, that I write here. Okay. Then I'm printing that nitrogen, phosphorus, and potassium here. Then timed out sleep, that idle time 5 seconds. And this one for uploading the data into cloud platform. Here I'm not going to, I'm not just printing the value on the screen. I'm uploading the value into cloud platform. Nowadays we need cloud computing, right? The processing may be done in cloud, and sometimes you want to get the value, the sensor values, you want to check the values from anywhere. Okay, sitting from any part of the world, you want to see that values, means I have a cloud platform, ThinkSpeak. I'll show you the ThinkSpeak platform here. In this ThinkSpeak, okay, this is my channel. So this is my project name, Revolution Agriculture Through Smart Farming by Employing Advanced Machine. I have which one, four, how many variables here, 6 variables. Okay, each one is corresponding to a sensor: temperature value, humidity value, soil moisture, nitrogen, phosphorus, potassium. Okay, potassium, all these things I can get the value from the program that is done through sensors. Then I can print it in my cloud platform. My cloud is thingspeak.com. Okay, so this one is free of cost. I'm using that which one, I'm not paying any money for this platform. So here I want to display the values before I keep on running the program. So the previous values I got, see, temperature started from 31. See the date, see, October 23. Today itself I started printing. Okay, I made the channel today. See the time also showing. I go there, it will show 31, then it is going down 30, like that, going up and down. Okay, temperature value which I get from the sensor. Humidity, see, humidity also 18, now it is 16. See, all those values up and down. Okay, the date also exactly October 23, 2025. So no cheating, same date. Now soil moisture also, see the values going up and down. What is the value now? Say this is the normal value, should be 559. This will be in between. If any errors come, no, this will be that error value. So 6555, 655, 30. They will not get that much value. Okay, the value will be like this. What's the value? 49D, 533, 538, 541. The nitrogen value like this, phosphorus value, potassium, all values, whatever you get here in the actual sensor, you will print in the which one, cloud platform. Okay, now I'm going to run the, before that I would explain few more things. Go to the program. This is my URL for my channel, cloud channel. Okay, so this, where is that cloud channel settings? Go to channel settings. There will be a key. There is the key. Go to API keys. Okay, So my key is AG78, this one, okay? The link is this one, HTTP API thing speak. So I'll go here and show you. This is my link. Then the AG something, that was a key. And how many values I want to write? I have to write 6 values, field 1, field 2, field 3, field 4, field 5, field 6. Then dot format of inside bracket you should mention the sensor values, temperature variable, humidity, SM for soil moisture, N, nitrogen, phosphorus, potassium, all variables which I'm using here, I'll put here. Then I want to make a new URL. That URL will contain this URL plus key plus header. All these three together, I make a new URL. Then I will open that URL. Okay. Then I will go for request URL dot URL open new URL. Then print of it. This I am going to upload the value into the cloud, and I will print that confirmation message also for that. This one URL package request dot URL open which URL, the new URL. Okay. This is the program. Now I am going to run the program. For that I am in terminal. So how do we run that? Python. Let me see here. Let me refresh the screen. Now I want to go inside the folder cd space home space py space texter space group py space software, then Python. Then I want to see the file name. See display the file name. Okay, it's small letter ls. The file name is, the project name is soil-project.py. I'll copy that project name. Then how do we run? Use the command Python 3, that Python editor, followed by soil-project.py. Put the project name. Then I will press the enter key. Now the output is coming on the screen. See, soil moisture. First time it will show some wrong value. Then later on it will change. Okay. See, it is showing which one, temperature is showing, humidity is showing, phosphorus, potassium. Then this message is the indication that data is uploaded in the cloud, like that http.cloud client http response object at this one. No, this is the confirmation that values are updated to cloud platform. Okay, see, the temperature, humidity, soil moisture, then NPK values, nitrogen, phosphorus, everything is now printed. Nitrogen, phosphorus, potassium, everything is now soil moisture 578. Okay. Now when I go back to my cloud platform, I could see channel settings here, public view here. Okay. So values are changing. See the time now 7:45. Now it is 7:50. See my time in my clock 7:51. 1950 50 point, see 57, yani 51 951. See, at this rate, at this time, what's the temperature? 30. And what about the humidity? Exact timing 1951, that means 7:51. Soil moisture value, that also coming on the exact timing. See, nitrogen value, phosphorus, everything you are getting in the exact, at the exact time. Okay. Now how we can download these values? Okay, where we are storing these values, we are putting in the cloud platform, but we can upload, we can export the data in Excel format, CSV format. Okay, so this one you can use this data import export, or you go for export recent data, that also possible. I'll go for this option first. So download this one. Okay, it will come in Excel format. I'll open that folder, open that Excel file. So whatever values, no, see all these values, whatever you are getting, no, see the date, time, everything is now showing. See 23/10/2025, the date also showing. See sometimes, no, if the sensor didn't read, no, in between the sensor will not read, means it will show not a number. Otherwise the values will be perfect. See all the, this is the entry one, first entry, second entry, third entry, entries keep on increasing. Okay. So now it is 31st. Once again I download, means it will be 32, 33, many entries will come. So in between, if the temperature humidity sensor didn't get a value, soil sensor not get the actual value, means show some default value. Okay. Actual values is 31, is the 31 is the entry, 31st reading. Then which one? This is the temperature 13, 30, humidity 40, 14, then soil moisture value, okay, then NPK values. When I try this again, so when I go and download this again, see when I download this again, see still the program is running, see, still it is running, it's still running. You can see that values, okay, 14, 590, it's 598 here, now it is 590, it's keep on running. So in that time, when I go and check that, which one, go to download that value again, you will get more entries. Let me download again, just refresh the cloud. Okay, this is a cloud platform, it is internet connected, okay. I'll download again. So here, now let me go and check the feed CSV, how many entries have been made. Now see, 37, what was the earlier one? 31. So each every second number of readings is increasing. Okay. Say after some say 20 minutes or 10 minutes or something, no, the number of entry will become say 50 to 60. So based on that, the values also keep on changing. See now 31 to 13, temperature 31, then humidity 13, soil moisture sensor value. These things see now 30, 14, 588, it keep on changing as the time passes. Okay, these things will change. This is what our but project related sensor values, we read actual values from the environment, then you are uploading into the sensor, uploading the values into the cloud platform like ThinkSpeak. Then I can download the actual values from the Excel sheet. The data get uploaded in the update in the Excel sheet, and you can download that value from Excel sheet for your testing purpose. Okay, that's what our project. These things will upload into our machine learning. We will have a machine learning model. Okay, whatever values we're getting in the machine learning, the actual sensors, no, this will be forwarded to machine learning model. From that, we can predict what type of crop is best for these conditions, this soil, this nitrogen value, this phosphorus, this potassium, this temperature, humidity. So all based on all these things, okay, what is the uh, recommended crop for all these conditions or situations? Okay, that's what our project means. Hope you understood.